Hey, what's up, guys? We're back. We left off talking about the phases of the moon, and hopefully you guys are getting out and seeing the moon this week, starting those observations. And we just want to come back. We've already hit most of this, but the lunar eclipses, we're going to talk about that, and that's when the moon is full and moves through the Earth's shadow. So it's during a full moon, moves through the Earth's shadow. It's kind of shown off in this picture here, and you can see the two different shadows. You got the umbra, that's the dark shadow that really blocks the entirety of whatever's behind it from the sunlight. And then you have the penumbra, where the sunlight is dimmed, but it's not totally out. The next slide here shows a diagram of a total lunar eclipse. The moon traveling from right to left in the figure. It moves through the Earth's shadow. And the photo at the top right shows the moon passing through the umbra of the Earth's shadow. So during a total lunar eclipse, we can still see the moon because light is shining on it, is the moon shining on the moon, and it refracts through the Earth's atmosphere. That means it kind of bends around the Earth's atmosphere. It bends through there and scatters most of the blue light, which is the light that makes it down to us, which is why the sky looks blue. Okay, and that red light kind of filters through and comes around. Lunar eclipses last pretty long. They can last 45 minutes to an hour or more. And so you're more often able to see them and actually get to view a lunar eclipse. Not as rare as a solar eclipse. Not all lunar eclipses are total eclipses, though, just like solar eclipses. Sometimes the moon only partially enters the umbra, and sometimes it is just a partial eclipse. If the moon passes through the penumbra but not the umbra, we call that a penumbral lunar eclipse. Fancy name. The moon is only partially dimmed during that phase. All right. Eclipses occur only between sunset and sunrise at your particular wherever you're at in your location. So only obviously at night when the moon is visible, and only at night when the moon is visible, but at night when the moon is visible. The table here can show you some of the lunar eclipses that might be visible and are coming up. It looks like for us we're talking in May 26th. And length of totality is only about 15 minutes, so a really short one in 2021, 2022. So still these things are fairly rare, but are occurring and can be are occurring about with the same frequency, which makes sense, but also they are visible for more or a large portion. Anybody who can see the moon during that time can see the eclipse. So part of what we want to get into here is something we call the small angle formula. All right, this figure shows the relationship between the angular diameter, so the size as far as the angular diameter, and distance of an object, how far away the object is. All right, the linear diameter is just the distance between the object's opposite sides. So you know the diameter of the moon linearly, not an arc or angular diameter, but the linear diameter of the moon. Farther away the object is, the smaller its angular diameter. So the smaller angular diameter it gets. This makes sense if you think about the sun. The sun is much bigger linear diameter wise than the moon, but in the sky they have the same or roughly the same angular diameter. They're both about a half a degree. We can calculate angular diameter in a unit called arc seconds using this formula. All right, you always got to make sure that you are always using the same distance units for linear diameter and for distance, because the units end up canceling out in this equation. If you could see the linear diameter in the on top and then the distance on the bottom. So if you use those the same units, they'll cancel. Let's look at an example. The moon's linear diameter, 3,470 kilometers. Its average distance from Earth is 384,000 kilometers. And the question is, what's the angular diameter? So how do we use this to find the angular diameter? You have the angular diameter on the top, all right, in the numerator on the left-hand side. And the denominator there, you have this number, 2.06 times 10 to the fifth. That is a constant that allows everything to work out. We won't get into where it comes from at this point, but just that kind of balances everything out numerically, that constant. And before you say that it's, well, where did it come from, whatever, it's important to know where it comes from. We'll talk about it maybe later I don't know if we'll have time to get into it, but the point is this equation allows you to calculate any one of the three values as long as you have the other two. In this case, we have linear diameter, as you can see, 3470 kilometers up top there, and we have 384,000 kilometers on the bottom. All right, and now those two, once we do that, that will give us our angular diameter divided by this constant. So that means we need to multiply each side by this constant on the bottom after we do the division. So we'll divide these two numbers, then we'll multiply by this constant, and you end up with 1,870 arc seconds, or what we call 31 arc minutes. All right, which is about a half a degree, which is what we see when we look at what we kind of knew about the moon already. As it happens, the moon is just the right size to cover the disk of the sun because they are the same size, so they have the same equal diameters of a half a degree. And when the moon entirely covers the sun, it's a total eclipse. When it only covers part of the sun, it's a partial eclipse. Every time the moon is new, its shadow points toward the earth. When the shadow crosses the earth, observers might see an eclipse, depending on where you're located for solar eclipses. Total solar eclipses, we've talked a bunch about those. We've talked about how amazing those are, so I'm going to go right through that. Here's another picture of the diamond ring effect. Doesn't happen for all eclipses. It happens depending on the orientation of the moon. It's actually a really cool thing if you do see it. It's even more rare because it has to actually, where the sun's shining through or as it's beginning to be covered, that last piece of the sun that's being covered peeks through a valley or a crater in the moon. So it has to, not a smooth edge, but a crater in the moon so that it gives it that space to come through and you get the diamond ring effect that you see here. Real quickly about annular eclipses. Annular eclipses occur when the the moon is not appear big enough to cover the entire sun. All right, the sun and the moon both vary in their distances to the earth, as you can see up here, the moon being as big as it is when it's close and as small as it is when it's far away. Same thing with the sun, it changes slightly as well. So these things have to work out perfectly and for us to have an eclipse. Predicting eclipses, we talked about that as it passes around those nodes in one of the other videos, and it's got to be at one of those specific spots to have an eclipse. Don't ever look at an eclipse. All right, this is a safe viewing space, but we've also got a way to do it with a pinhole and some cardboard, or you can make it out of a box. There's a couple of tutorials if you look up on YouTube of making them out of just a cereal box. Those are pretty cool. It helps. You can see the shadows, you can see the visual, but you won't be able to actually see the sun covering because you're not looking directly at it. You're looking at the cardboard and the shadow that's being presented there. They make glasses that are available for solar eclipse viewing. They are pretty dark, polarized glasses, polarized in the way that's opposite of the light coming from the sun. So total annular eclipses, we've already looked at that. So hopefully you are going to stick around or put that date of, is it on here? Yep, April 8th of 2024 on your list for the total solar eclipse in North America. It's going to be right near, here it is right here. It's only going to last a total of 4.5 minutes. 4.5 minutes. So versus a lunar eclipse, it's much shorter. And it looks like it's going to occur at about 1800 hours UTC. So that's going to be subtracting 5 hours. So that's about 6 p.m. So about 1 p.m. in the afternoon on April 8th, 2024. So check that out. Put that on your calendars. We'll see you guys next time.